Welcome to Sustainability Matters. I'm Tria Case, CUNY's Executive Director of Sustainability and Energy Conservation and your host for Sustainability Matters. Today's topic is energy storage. Energy storage is a requirement for New York City's clean energy transition, promising to provide resilience, reduce grid congestion, and the flexibility needed to replace fossil fuel plants with renewables. Pairing storage with renewables like solar and wind can provide New Yorkers with increased reliability and resilience, allowing these otherwise intermittent resources to be available when we need them. Here's Ari Goldberg with an overview of battery energy storage.
We've talked a lot on our show about renewable energy like solar and wind, but of course, there is a hurdle there. What to do when the wind isn't blowing or the sun isn't shining? That's where energy storage systems come in, and specifically batteries. Now, there are different types of energy storage systems that harness power for use at a later time. But battery energy storage systems are currently the dominant storage technology for power plants to use in conjunction with renewable power. There are several kinds of storage batteries, but by far the most prominent type for global energy storage is the same kind found in phones or electric cars, lithium-ion batteries. Broadly speaking, all batteries have one electrode that likes to give away electrons and one electrode that likes to take electrons. Think the positive and negative ends of your typical kitchen drawer battery. That flow of electrons, of course, is electricity. Lithium is a very lightweight metal that is very reactive. That is, it moves its electrons incredibly easily, meaning you can pack a lot of electric movement in a small, light package. And that's an ideal substance for a battery. That reactivity is also what can make poorly constructed or poorly maintained lithium batteries dangerous, like when you'll occasionally see a news item about an electric scooter battery lighting on fire. Of course, the safety precautions are far more reliable when it comes to grid-scale battery storage. By the end of 2022, total worldwide battery storage was projected around 27 gigawatts, with America around 9 gigawatts, China and Europe being the other market leaders. For context, your typical home light bulb is 60 watts. A gigawatt is 1 billion watts. To put that in perspective, though, the US power grid has a total capacity of around 1,300 gigawatts. So what's even the point of a drop in the bucket like 9 gigawatts? Well, first of all, batteries aren't intended to run an entire power grid endlessly, those hundreds of gigawatts. What they can do, however, is complement a grid's weaknesses and supplement its strengths. If there's a potential blackout, batteries can be turned on virtually instantaneously to provide backup power until the problem is fixed. When there's a particularly windy day, they can store extra power from wind farms for later. When there's a cloudy day limiting solar panels' contribution to the grid, the batteries can send out power to smooth out the discrepancy. It can also limit emissions. For instance, when New York's having a peak in energy demand, like in a heat wave when everyone's using air conditioners at once, the city uses a series of 16 peaker plants to fire up rapidly and produce the extra electricity. Well, batteries can perform that same job, and without emitting the roughly 2.7 million tons of CO2 annually that these fossil fuel peakers do. And that's good for public health justice, too. Neighborhoods, overwhelmingly minority, near Queens' Ravenswood Power Plant, which supplies roughly 20% of the city's power, have been called Asthma Alley, and development is in progress to turn the plant into a green energy hub, featuring a large investment in battery storage. Adding battery storage is a major component of New York's net zero emission plan. In 2022, the state released its Energy Storage Roadmap 2.0, calling to add 6 gigawatts of storage, doubling the original 3 gigawatts aim, enough to power about 1.2 million homes. Federal and state incentives and tax breaks are helping this adoption, as are local incentives, like Con Ed offering rebates for installing your own battery project. Of course, there's a lot of red tape, so many places around the world are wrestling to streamline the process. In New York, for example, Sustainable CUNY, under Tria Case, is partnered with the city on its Smart Distributed Generation Hub to be a one-stop shop for guidance on the permitting process. But rapid adoption is not unique to New York. Lithium-ion batteries have become more advanced and more accessible around the world as demand has increased, for electric cars and electronics, as well as energy storage. These days, Australia is the largest by far producer of lithium, but it is China that is the biggest consumer and battery producer, controlling most of the world's lithium processing facilities and producing around 3/4 of the world's lithium batteries. International supply chain competition that the United States is working to address. By 2021, global investment in battery storage reached almost $10 billion, and battery power costs dropped from $1,200 per kilowatt hour in 2010 to just $151 by 2022. However, in recent years, lithium prices have fluctuated as supply has not kept up with demand. And as we look to the future, that poses a challenge. While growth has been rapid, the International Energy Agency projects that to reach the goals of the Paris Climate Accords, we'll need to aim higher, boosting global storage totals from 2022's 27 gigawatts to 680 by 2030. For Sustainability Matters, I'm Ari Goldberg.
We're here with Sanjoy Banerjee. He's a distinguished professor of chemical engineering at the City College of New York, and he's the director of CUNY's Energy Institute. Professor Banerjee is also the founder and chairman of the Urban Electric Power Corporation, spun out of the CUNY Energy Institute. Professor, welcome.
Thank you so much, Tria. So nice to be here.
It's good to have you. So tell us a little bit about the Energy Institute and the types of things that you're focusing on.
It was an initiative which we started, really initiated by Andy Grove, who, as you know, was a City College alumnus. And he wanted to develop sustainable energy technologies with low carbon footprints. He was a visionary, obviously, at that time, which could reduce our dependence on foreign energy sources. So that's how the Energy Institute got going. And we developed technologies which others weren't doing, So part of it was to develop energy storage technologies, but not lithium-based, because there were lots of people doing that. So we looked for technologies that we could contribute to, that would really make a difference, but not something that was already being heavily researched.
Beyond lithium.
Beyond lithium.
You actually worked on a project that turned into a battery that you've now brought into the marketplace. And I know you worked with students and faculty and brought together a lot of CUNY folks.
What happened was, when I came here, we started working on this sort of beyond lithium technology, and it looked like zinc was a possibility. It was abundant, inexpensive, safe, etc. And also it was used in your primary batteries. So the supply chain for zinc to use in batteries was well established. Then we looked at different sort of combinations, zinc air, this, that, and the other. And in the end, ARPA-E funded us to try and take the technology you have in your AA's and your AAA's, which are single discharge, and make it rechargeable. That was really the lowest cost option you could probably think of, because these were of the order of $10, $15 a kilowatt hour.
Right.
But single discharge. So part of the ARPA-E award was to try to make these materials in there rechargeable. And that was the breakthrough we were after. And of course, there was a big team assembled. This was a $6 million project. And also, of course, New York helped. Our Senator Chuck Schumer got some money also put into it, and NYSERDA. So all in all, with this, we were able to successfully get these to become rechargeable.
And you're doing a little bit of recycling, I think, in that facility, right? Is that an old manufacturing facility that you were able to?
There is a outfit in Port Colborne, which is not too far, which actually takes the manganese dioxide and makes it into fertilizer for corn. So it's possible to do that, and the zinc as well. But we don't do it at Pearl River.
But you've figured out the sort of supply chain to what happens at the end of life of those batteries.
It's very important, really, yeah.
What do you see as the role for battery storage in our urban environment and sort of, going forward into the future? We certainly talk a lot about the lithium-ion batteries. You've now developed an alternative to that. What do you see the makeup in the coming years as we look at meeting these, these very big goals that have been set, both, in the state and beyond?
I think we need all the technologies we can, really, to try to meet the demand. Lithium is light, and it's particularly suitable, therefore, for electric vehicles. But, if you supply the electric vehicles with electricity from fossil fuels, you actually are defeating the whole purpose. And that has to come from renewables of some sort, solar, wind, hydro. And battery storage is essential to take care of the intermittency problem. The sun doesn't always shine, the wind doesn't always blow, and therefore the batteries come in and meet the demand when they don't. They can store electricity. Now for the grid, the lightness and so on is less important than being able to have something which is really inexpensive, like zinc or iron or something like that. So I think for these types of applications, storing the wind or storing the sun, you do need an inexpensive, safe, and really non-flammable systems which can be put in very large sort of establishments. We can also look at storage at the residential or commercial and industrial level, so that we put these systems to increase resiliency within homes, buildings, and so on, as well as storing electricity near the use point rather than putting it somewhere else.
Right. More efficient, closer to where the power
where it's being used. So I think there is going to be an increasing need for distributed storage.
So at the Energy Institute and at City College, you have a smart grid effort going on, and battery storage, I guess, is part of that. What are the types of things that you're engaging your students and faculty in terms of helping to get us to this goal of distributed storage?
So we have a grid modernization center, which is being formed at City College under the Energy Institute. Professor Ahmed Mohammed is heading that. He's an electrical engineer. And we have storage as a component, but one of the most important functions we have there is also training and workforce development. So we are making a control room which will simulate some of the more important functions for the smart grid. And we've got Con Ed, for example, involved, and a number of other utilities and so on. So we hope that it'll be successful. There's a lot of enthusiasm for it, because there's going to be an evolution in the grid as we go forward. As you say, into a more distributed form and different business models and things like that.
So you're
controls.
You're training the students for the future grid.
Yeah, we hope.
It's amazing the work that you're doing at the Energy Institute, and thank you for coming here and sharing your expertise and your thoughts with us, and look forward to continued working with you. Yeah.
Thanks, Rhea. It's a pleasure.
Now let's go to City Island in the Bronx, where Mary-Eve Ami went to visit an energy storage site. The installation is a great example of how energy storage can help defer billions of dollars in infrastructure upgrades on power stations and make the grid more reliable. We'll also meet a member of my team at Sustainable CUNY, our storage ombudsman.
Hidden inside an industrial lot sits City Island's first community energy storage system. It was first installed 5 years ago.
This is actually one of the first demonstration projects that we constructed here in New York City with Con Edison. It actually looks something like a data server room. You can see racks and trays. Instead of servers, there's actually lithium-ion cells in each of those racks. This is the transformer owned by Con Edison. It's then stepping up our 480 volt output to 4,000 volts. That's actually what's out on the system on City Island Avenue here on the poles and wires.
The location was chosen based on Con Edison's analysis that showed the electrical grid needed support. When Con Edison is not using the energy storage unit for grid support, Endurant Energy plans to dispatch power from the system into the wholesale market.
City Island actually is a kind of unique grid system. It's a 4,000 volt system out on the street here. There aren't actually that many ways to get into City Island. It's literally an islanded grid here. So this is a way to actually manage the voltage and actually prevent what might end up being brownout conditions. And the nature of community storage, this type of storage, is really aimed at actually preventing billion-dollar type investments in substations. If you can offset really that peak demand in the summer and you have enough megawatts of storage or other DER, you can defer for many, many years really, really substantial investment on the utility side. And we actually have, this is the first, we have 3 altogether. There's another one in Staten Island and another one in Queens and Woodside.
Installations like these involve navigating a complex and ever-changing landscape of rules and regulations. That's where the CUNY Smart Distributed Generation Hub comes in. Born out of Sustainable CUNY, the Smart DJ Hub has emerged as a key player in the development and installation of energy storage in New York City.
My fellow ombudsman and I, in our day-to-day work, we interact with a lot of energy storage and solar installers and other service providers in the renewable energy industry on helping to essentially demystify and understand and navigate the codes, standards, rules, and regulations that govern installations like this. Being based out of the university, out of CUNY, we're able to tap just a really wide variety of subject matter experts as a sort of quasi-city agency. Also, we do 3 main things: the outreach and education, guidance documents, that kind of thing for the industry, helping to facilitate the agencies with whatever support or assistance they may need in terms of developing and refining and sort of streamlining their own rules and processes, and documenting all of that stuff and disseminating it.
Often you have to turn to CUNY DG Hub or a New York BEST to kind of create ad hoc working groups for specific issues that might just emerge from policies or new rules that you didn't even know about the year before. And it's hard as an individual developer to just go and kind of fight those battles on your own. You really need the support of trade groups and other policy support people and other developers to come with you. So yeah, the CUNY DG Hub is critical for that.
For Sustainability Matters, I'm Maria Vami.
Welcome back. We're here with Dr. William Acker. He's a well-known and highly regarded scientist, business leader, and entrepreneur in the field of energy. He currently serves as the founding executive director of New York BEST, the New York Battery and Energy Storage Technology Consortium. Welcome, Bill. Thank you for being here with us.
Glad to be here, Tria.
Can you tell us a little bit about New York BEST and the types of things that you've been working on in order to help grow the market over the last decade?
Sure. New York BEST is a nonprofit organization. We have about 175 members within our organization that are a mixture of universities, companies, the companies throughout the entire supply chain, equipment manufacturers, developers, everybody involved in deploying and creating energy storage products in the marketplace. We do a lot of work to advance the sector. Our mission is to grow the energy storage sector and make New York State a leader in this sector. We do work in policy to make sure the market rules are right so that these things can be deployed. We do work in helping startup companies grow their companies, in helping product development. And when we talk about energy storage, we're talking about energy storage for the grid and for electrified transportation and for a number of other applications. So our actions over the past decade have really been around creating the environment in New York State for this industry to thrive.
And New York has set some very ambitious goals around battery storage and deployment. What do you think needs to happen in order for us to realize those targets and that vision?
New York State has done a great job of setting some really aggressive goals. The governor doubled the energy storage target to 6 gigawatts last year, and the state put together an energy storage roadmap. And really importantly, the state worked very closely with New York Best, our members, and a lot of other people to look at what were the barriers and to get those barriers reduced to be able to deploy these products. A couple of the key areas for that are the policy recommendations within the roadmap, and this roadmap right now is in front of the Public Service Commission, hopefully will be approved soon, but the policy recommendation is to have programs like we have for wind and solar in order to deploy the products because there are market barriers for energy storage. Second big barrier for energy storage right now is the interconnection of the storage products, and this is something where you don't think about it, but in order to put these things on the grid, you need to interconnect them to the grid. And as we're changing the grid, we used to have a grid where everything that was put on basically put out energy all the time. Now everything's putting out energy at different times, so we need to have a lot more of it connected to the grid. When we have more of it connected to the grid, if we have rules that say everybody must put out energy at the same time, you have to overbuild the grid. And right now we're facing that, so the costs of interconnection are very, very high in New York State, so we have to change our interconnection rules. The last thing we need to do is we really need to work on the supply chain because energy storage is a global industry. We're competing against car manufacturers in China, against people in Europe for the batteries. We need to have domestic sources of all these products. Plus, having domestic sources of all these products makes jobs in the United States. So really the benefits for New Yorkers of those jobs.
What is the number of jobs that we've been assuming would come to New York State with these efforts?
Yeah, it can be a lot. A few years back, New York State made an estimate that energy storage industry could create 30,000 jobs in the state before 2030. And I personally believe that's even a conservative estimate right now with the rapid growth of our industry.
And you're working on a supply chain consortium that is creating some databases so that people can understand what is happening in New York State. Can you talk a little bit about that?
Certainly, that's correct. We're part of a group called New Energy New York that is working to help to grow the ecosystem in the state. And part of our role, we're leading the supply chain effort for that. So part of our role is to create a resource that everyone can use to connect and to be able to have companies interact and have the opportunities to have local suppliers, and also that our resource database looks for MWE suppliers, veteran-owned suppliers, really helping to focus people on the local economy as we're doing this. So we just recently launched that database just a few weeks ago, so you can see it on our website. We also are working very, very hard to recruit industry to the state and to help to streamline the growth of those industries.
We'll be looking forward to talking to you more about the jobs that will result from all of those efforts. So we've been covering solar and wind and the grid, and you just spoke a little bit about how we have started to transition to renewable resources. What's the role that storage plays in helping us to make that transition?
When you look at how much is required, the governor doubled the goal to 6 gigawatts recently. And by the way, we used to talk in megawatts, now we're talking gigawatts. That's 1,000 megawatts, it's big numbers. But in fact, the projections call for about 15 to 20 gigawatts of energy storage needed in order to balance as we go for a fully decarbonized grid. That's about half the full electricity generation in New York State today. So we need a lot of this, and we're going to need it in a lot of different forms. We're going to have it in batteries at people's homes, in batteries at industry, but also in long duration storage, other forms of energy storage beyond batteries that are going to be able to use to balance the grid.
We also see batteries in things like e-bikes or other items that are folks are using in their homes. Can you talk a little bit about the difference between those batteries that we've been hearing about and these larger scale batteries that we're relying on to help us with the grid?
Absolutely. It's important to recognize that when we talk about batteries, we talk about the term energy storage, we're talking about storing a lot of energy. And when we're talking about storing a lot of energy, you really need to design that system safely. Because if you don't, there can be catastrophic events. And so, we need to have safe manufacturing, good manufacturing, you need to have good product design, you need to have good deployment. Energy storage systems for the grid go through a whole group of codes and standards to ensure that that occurs. So there's testing of the batteries themselves to make sure that they're safe. There's evaluation of the manufacturing processes to make sure they're manufactured safely. And there are a whole host of codes and standards around the deployment and the siting of these devices. Unfortunately, for a lot of other applications, those rules don't exist. And so when you look at the situation with e-bikes in the city recently, you've got a lot of batteries that don't go through any of those safety checks, that are usually manufactured as cheaply as they possibly can be manufactured. And importantly, also may not be operated in the right way. But I think it's very important that you do understand that there's been an immense amount of work in the industry to make sure that we can deploy energy storage properly.
Mm-hmm. Thank you for sharing your expertise with us, Bill, and for coming here, and I really look forward to continued work with you.
It's been a pleasure, Tria. Thank you.
Thank you. You can find out about career options on the Department of Energy website and explore the many courses, undergraduate and graduate degrees that CUNY has to offer at cuny.edu. Please keep the conversation going and follow CUNY TV or send us a message on Instagram or Facebook. Thank you for watching, and tune in next month when we discuss electric vehicles.